Hi, and welcome to this short video going over IGCSE Marine 6.5, which deals with power from the ocean. This is mainly to do with fossil fuels, transport and drilling, and with renewable energy. As always, this is made for my own class, but anyone is welcome to use it. And any mistakes here are mine alone and does not reflect on Cambridge. As always, when you're looking at Cambridge, it's a good idea to take a good look at the syllabus because, especially here in the sciences, the syllabus states really clearly what you need to know. So you need to be able to know that oil can be found under the seabed, how it's created, and describe oil as a non-renewable fossil fuel that can be used in many ways. Combustion and plastic are the two ones they mention. State that oil is extracted and transported around the world, and there's a risk of oil spillage. Talk about the MARPOL rules, how to make modern ships and oil tankers less likely to have accidents. You need to be able to describe the potential impacts of oil spill on marine ecosystems, discuss strategies for minimizing the impact of oil spills, discuss the environmental, economic, and social advantages and disadvantages of using fossil fuels, and discuss the same things for renewable energies, where they talk about wind, wave, and tidal. So the main energy source when we're talking about the ocean here is drilling for oil. Oil has been formed over a long time when small plants and animals had died, they sink to the ocean floor, and then under time and pressure, they are turned into fossil fuels. In this case here, we're talking about oil and gas, but you can also talk about coal. And fossil fuels like this has powered our industrial revolution. It has given us a stable source of energy, and many things in our homes today are created from this, from clothing to plastic. It has also had a huge impact on the environment and has led to global warming. So it's some pretty important subjects that we are discussing here. So this map shows our current proven oil reserves. Many of them are, of course, under the seabed. And many of the oil reserves, which are easy to reach, are already being exploited. So some of the unused oil fields are either harder to get or requires more work and have less output. Where these oil fields are, of course, has a huge impact both on our global energy supply, but also on our political environment. So it's going to be a huge debate in the future where these are and should they be used and who's going to use them. So if we want to reach the oil reserves, the natural gas reserves, we've got to drill for them. Many of them are below the seabed, so that requires constructing and moving an oil rig. These rigs can either be floating or they can be anchored to the seabed, depending on how deep the ocean is at that point. And then there will be drilled a hole down to the reserve of the fossil fuels, and then that can be pumped up into the oil rig, and from the oil rig it can then be moved around the world where it needs to be placed. So then the oil needs to be transported from the oil rig to other locations, usually to a refinery, because the oil we get up from the sea bottom need to be separated into longer and shorter chains, and that is done at a refinery. And then the oil needs to get moved to wherever it's needed, and that is mainly done in these big ships, which oil tankers, which sail the fossil fuels around the world. And sometimes ships they crash or they sink, and when that happens, there is a risk of oil spills, which can be very damaging. So there are now rules made to minimize the risk of oil spills. The rules are what we call the MARPOL rules, and the MARPOL rules have been since 1973 a work to minimize the risk of transporting oil on the ocean. Most important is that all new tankers must be fitted with a double hull, which means that if there is a collision, there's less chance of oil leaking into the water. There are still old single hull tankers sailing out there on the ocean, and they prove a much higher risk of pollution than modern double hulls. Also, tankers can only be washed out when they are at special collection site of ports, so they can't just flush the tanks with seawater out at the ocean and thereby leaving oil at the surface. Sewage and garbage must also be controlled, so it's not just dropped in the ocean, but is collected at specific collection points. So these rules here, if done um, correctly, will minimize the impact of any possible oil spill and will also minimize the pollution from oil tankers. Now, the marine environment can be a harsh environment and accidents can happen. Ships can get caught in storms, they can hit reefs, they can hit each other, there can be human errors. So oil spills can happen, and oil spills usually either happen from a damaged pipeline that can be at the drilling area, or it happens when ships they collide, they crash, they get damaged. When that happens, oil will start by floating on the surface because oil and water does not mix. But wave action can break up the water and the oil into smaller oil droplets, and some of them can then sink to the bottom of the ocean and form like a tar-like substrate at the bottom of the ocean that can be real damaging to marine life. There have been some quite famous crashes and oil spills. If you want to look into them, you can look into the Exxon Valdez, where you had a ship that spilled a lot of oil in a very pristine, active environment, which made cleaning up very difficult. The Deepwater Horizon accident was an accident where there was an explosion and a fire at an oil rig in the Mexican Gulf. So the oil kept leaking from the burning oil rig, which led to a huge pollution of the Mexican Gulf, and cleaning up after this has been a major endeavor. Now, when we have oil spills at the ocean, this can have a huge environmental impact of the organisms living there, both in the open sea and on the coastal ecosystem. Oil, if it coats fur and feathers, since oil does not dissolve in water, it is very difficult to wash off, and the fur and feather then lose their insulating effect, and the animals often die due to hypothermia. After an oil spill, you'll often see people trying to clean off animals that are covered with oil, and they need a very special treatment to that, and it's not always possible to clean off the animals. Oil can also contain many chemicals, and some of them can kill animals that eat them. Some birds will consume the oil when they try to clean their feathers. Predators can get the oil in when they eat oil-covered animals. And this can also lead to disruption of food chain. Also, when oil they cover the surface of the water, it reduces the amount of light for marine producers, thereby also damaging the ecosystem. So we really want to avoid oil spill at all costs. So if we had an oil spill, then we need to get rid of the oil. And of course, we need to combat the damage to the marine organisms, such as mammals and birds. But the most important is to get rid of the oil. And there are several ways. On the image here, we see a boom, and boom is a floating barrier that is used to try to limit the spread of the oil so you can pump it up. Skimmers are devices that are used to suck in the water and the oil and then remove the oil from the water. Dispersant sprays causes the oil to break into smaller droplets, so that removes it from the surface, but unfortunately these smaller droplets then sink to the bottom of the ocean and damage the ecosystem there. And lastly, there is the option of controlled burning, which of course releases a lot of smoke and can release sulfur dioxide and other things, but can also remove a lot of the oil from the surface. But of course, the best option is do not get the oil onto the surface of the ocean. So there are advantages and disadvantages to using fossil fuels. The advantage to fossil fuels, the main one is you have a constant and reliable energy supply. As long as we can drill out fossil fuels from the ground, we can then burn them, and that can be used to create energy. We can use them for plastic and so on. They're also quite energy dense, and they're easy to store compared to some of the non-fossil fuels. The disadvantages are that they're non-renewable. The more oil we take, the less there is left in the ground. It will take millions of years to create new fossil fuels. Also, and this is the big thing, they release a lot of carbon dioxide, which leads to global warming and climate change. They can release sulfur when they're burning, which is also a pollutant. And extraction and transport can lead to a lot of damage to the environment. Luckily, oil and gas are not the only ways we can get energy supply from the ocean. In the recent years, we've seen a huge growth on renewable energy sources being used from the ocean. And personally, I think it's better to invest in them than keep drilling fossil fuels out of the ground that will increase global warming. Renewables, which means that once we place the infrastructure, they will keep on creating energy. And we often look here at wind turbines, but we're also going to look at a few others. They are quite smart when they're there, and they reduce our dependence on fossil fuels, and they will reduce the impact of global warming. But they can be quite expensive to build, so there's a high initial cost. There are also a limited amount of good locations available. You need to place them a place where there is wind and where you can also have the energy infrastructure to have the power cables going back to land where you need it. Underwater cables need to be placed. There can be damage to seabed. The weather can be quite harsh out in the ocean. That can damage the turbines. Marine life who get caught in the turbines, especially birds, can be damaged or killed by strikes. There is a high cost of maintenance, and some places there can be a conflict with tourism if people expect a coast with no wind turbines. So far, we mostly talked about wind turbines because they're the one being used the most, but there is also the possibility of using the movement of water in wave power, tidal power, and ocean current turbines. And a lot of prototypes have been built, and we do have both wave power and tidal power stations working already. So the movement of water will contain a lot of energy, and that can be used to power a turbine. The issue is, of course, doing it in salt water is highly corrosive, and the machines who need to operate in salt water need to be quite stable. That can lead to a lot of issues, but can also create a lot of energy. Of course, we need to think about the possible damage to marine ecosystems as well. If we place like huge power stations, places where organisms need to go for breeding and so on.